So, we need a test for linear independence. And really, as far as you guys are concerned, for linear independence, what this really gets down to is something like y is c1 y1 plus c2 y2, where y1 and y2 are functions, is actually, this is kind of an IE, the sort of solution that can handle two initial conditions. So what I mean by this is it's not this case we just talked about where we have y is a e to the minus 2t plus b e to the minus 2t. Like, this is linear dependence because those are the same function. This thing's only going to be able to handle one initial condition.
So basically any time they're different.
Yeah, so this test doesn't feel super useful in here because you're going to be able to eyeball whether two functions are linearly dependent or not. Like, most of the time it's going to be glaringly obvious. That said, this thing is kind of useful if you think that a function might be a linear, an algebraic rearrangement. You guys see that? Like, if you're just not sure whether that's how fractions work or something, or exponents, like sometimes you can use this to check.
Joe's looking at someone.
I'm looking. Yeah. So,
I'm hella good at fractions.
I'm hella good with fractions and occasionally pretty good with exponents, but every once in a while.
I read almost every day in algebra too. I'd be like, hey Joe, is this right? He'd be like, what are you doing? No, God, no.
Okay, anyway, the way you do this is you calculate this thing called a Wronskian.
That's W.
Spelled.
That sounds like a food. I would totally eat that. Anyway.
Wronskian, I think.
Disease.
I had somebody correct my spelling on a YouTube video this morning, so now I'm kind of
Really? What was the word?
consistent.
Oh no.
Whatever.
Spelling is
Anyway,
inconsistent.
Wronskian of two functions is the first function times the second function's derivative minus the second function times the first function's derivative.
And if that's 0, then we have problems.
Good. And then, yeah, you check if this is 0. So, if the Wronskian of y1 and y2 isn't 0, in other words, it has no zeros, this is not an identically 0, this is a never equals 0, on an interval AB, then y1 and y2 are linearly independent on that interval.
So
You guys cool with this?
Not equal 0, not identically equal 0
Yes. This is very specifically not a triple equal sign.
on an x interval AB,
Yep, on an x interval AB, or a t interval, or whatever the
dependent
dependent variable
or
is.
independent.
Independent, thank you. It is still the independent variable, in spite of the fact that I'm testing for linear independence.
So there's like a half quotient rule almost.
Yeah, it feels a little bit like a quotient rule, right? It's
oh yeah.
so it's really the determinant of this matrix. y1, y2, y1 prime, y2 prime.
Okay, I actually know what this means.
They can
Let's
do
go.
that now.
Oh man.
You see number one.
Yeah, so this is if you want to memorize the Wronskian this way, that's
Is
also
this
an option.
like a differential Jacobian?
Yeah.
Oh.
No.
Oh, of course, because the
Oh, it all makes sense now. These things are bases.
Yeah.
Oh.
So, if you have linear algebra, some of the words that Chris is saying will make sense. This is a question about a basis. And a
Oh my
function
god, that's
space.
amazing. I have to cheat now. with
No,
it.
we're not there yet.
No, you're probably not there yet.
like next week.
Just remember this for later.